Okay, we'll look at the new chapter, chapter 7, eigenvalues and actually eigenvalue and eigenvector. So chapter 7 is related to eigenvalue and eigenvector, and you use the numerical method, so-called power method and shifted power method to find the dominance and the dominant eigenvalues and the smallest in terms of magnitude for the I mean you'll find only one is the most dominant, another one is the least dominant using power method and the shifted power method. Eigenvalue and eigenvector here are actually used to solve system of differential equations. And then the stability of the numerical scheme to solve the PDE differential equation we'll learn in chapter 8, but your syllabus is only one single differential equation, not system. And then also eigenvalue and eigenvector also use in finding the stability of the numerical scheme to solve your PDE equation, which is the last chapter, chapter 9, and many other applications. So for your information, for an n by n matrix A, mean a matrix A, let's say you have a let's say if 2 by 2, then you should have a 2 eigenvalue. If a matrix A is a 3 by 3, dimension 3 by 3, then you should have 3 eigenvalue. So that's why general, if you have the dimension n by n matrix A, then you will have up to n eigenvalue. And then each eigenvalue, they have their corresponding eigenvector. So lambda 1, will pair with V1. This is a mean corresponding eigenvector for lambda 1. So lambda 2 pair with V2, lambda 3, V3, and so on. And then what we mean the dominant eigenvalue is actually the largest in terms of magnitude. Let's say you have up to n eigenvalue. If the magnitude of a lambda 1 is greater than magnitude of a lambda 2, greater than lambda 3, and so on up to greater than lambda n, hence lambda 1 is what we call the dominant eigenvalue, mean the maximum in terms of magnitude. And using power method, you can find this dominant eigenvalue. Can find only one, and then later on, if you use shifted power method, you will find the least dominant or the smallest in terms of magnitude. To find the eigenvalue and eigenvector, using this power method is actually sorry, k should be start from 0. Sorry, the k actually we start from 0. So given an initial eigenvector, you have a k0. So given the initial eigenvector v0, we put it v superscript here, stand for the initial eigenvector. Let's say we use the case A is a 3 by 3 matrix, 3 by 3. So vector is a column. So it's your 3 row, one column. So the number of column of A is equal to the number of row in vector V. Hence A and V can be multiplied. The resultant A times VK is a 3 by 1. I mean the result is a 3 by 1. It's a 3 by 1 means you have a column vector. So mean A is a matrix constant value. Given the V nodes, and then you multiply A V nodes, you get the result is a 3 by 1. 3 by 1. And then so you got 3 value there, and then you find the maximum absolute value of the resultant AVK here. So that is what we denote as a MK plus 1, MK plus 1. And then you take AVK divide by MK plus 1. Mean given given V nodes, and then you do AV nodes. AV node, you have 3 value there. The result is a 3 by 1. 3 value, you get the maximum. okay, get the maximum value, which is the mk plus 1. And then you take your avk divide by mk plus 1. That will be the, okay, uh, v number 1, because when k is 0. So that will be the, okay, better eigenvector v number 1. And the process is, okay, repeated until, okay, the mk plus 1 minus mk, magnitude mk plus 1 minus mk less than epsilon. Then the dominant eigenvalue is given by, okay, dominant eigenvalue, this one, lambda 1, is given by mk plus 1, and its corresponding eigenvector is given by v1, is actually v at the k plus 1 step. Okay, this is, okay, maybe now you can understand. When you look at the example, you can, okay, understand better. Okay, for example, okay, we have a eigenvector, we have a metric A is, okay, 3, negative 1, 0, negative 2, 6, negative 2, 0, negative 1, 3. Find the largest, okay, eigenvalue lambda 1, okay, okay, the largest in term, actually, in term of the magnitude, mean, take, okay, if a negative, we will take the magnitude. So the largest eigenvalue lambda 1 in term of magnitude, and its corresponding eigenvector v1, okay, using power method with, okay, v, okay, mean the, okay, initial eigenvector v superscript 0 equal to 0, 1, 0 transpose. Okay, this is, initially eigenvector is a column vector, okay, column vector, mean 3 row times 1 column. To save the space, we turn it to row. That's why we put it transpose. Mean initially eigenvector should be 3 by 1, 0, 1, 0. So here don't put comma. Comma is a coordinate. So initially it should be this form column. To save the space, we transpose it. Okay, so that's why I got the T there. Then stop the iteration until, okay, magnitude of mk plus 1 minus mk less than epsilon equal to 0.005. Okay, for this subject, we standardize the calculation using 4 decimal place. So for each step, make sure you just show 4 decimal place. Don't make sometimes 2 decimal place, 3 decimal place, 5, and so on. You see all the example here, okay, all the books. We standardize 4 decimal place, then all the calculation you use 4 decimal place. Don't mix around. Okay, you make, okay, you mean if you mix around, okay, you not standardize it. Okay, so this one, okay, this is a table. Why we vk transpose? Initially is, okay, column. To save space, we turn it to row. That's why this one we denote vk transpose. K start from 0. Okay, and then mean, okay, just now given, I think the v naught is 0, 1, 0. Given v naught 0, 1, 0, so you put it here, 0, 1, 0. The initial, okay, eigenvector 0, 1, 0. Later on, you have to find A multiplied Vk. Okay, so what's the metric A? Just now. 3, negative 1, 0. Let me jot down first. Okay, so mean, okay, okay, and then, okay, this one you will intensively doing A. A is metric, okay, V is a vector. We can, so you can also assume it this is a matrix 3 by 1, 3 row times 1. That's why we'll use, okay, the matrix mode to do this matrix multiplication. Instead of you do manually, okay, of course we'll get the careless mistake there. Okay, so I need to jot down here for you to see. Okay, A is 3, negative 1, 0, negative 2, 6, negative 2, 0, negative 1, 3. Where's my mouse? Oh, yeah, one. Okay, you go to find the matrix mode in your calculator. Okay, this one is number 4. So we are going to key in the matrix A into your calculator. So I choose, okay, number 1, max A, the matrix A, 3 rows, 3 column. So those MS, you cannot see this, okay, natural display. You only see one element by one element. Okay, only ES onward you can see the natural display like this. So input, okay, matrix A into your calculator in matrix mode. So 3, -1, 0, and then have -2. Okay, input row by row, element by element from first row, second row up to third row. And then you have 0, 6, 0, -1, 3. Before you perform any calculation, please double check whether you input correctly. 3, -1, 0, -2, 6, -2, 0, -1, 3. Okay, so you have, okay, successfully input the matrix A into calculator. Okay, later on we want to do matrix A multiply vector V. Yeah? Vector V we can, okay, 3 by 1 also can be, okay, a matrix. So to input another matrix, okay, for this model I press options. Okay, and then I define matrix, okay, number 2, 3 rows, 1 column. So it give you, okay, matrix B. Okay, means A I input as A, B here input as a B in your calculator. This is a B. Okay, so input the vector V as B. You have 0, 1, 0. Okay, so now we want to perform. You already have A, you have B. So you take, okay, matrix A times K times B. Then you will get this result here. You should get this result. Okay, so AC to clear first. And then, okay, for this one I press option. Okay, your old model you have to find, okay, where to press it. This one options, okay, matrix A number 3, multiply, just a multiply button, multiplication button. Okay, then option, find back your matrix B number 4. So I get -1, 6. Okay, you can go -1, 6, -1. There's this result here. So mean, okay, for power method, given initial eigenvector 0, 1, 0 is a column. To save space, we turn it to horizontal to row. That's why we see here VK transpose. Okay, and then, okay, input, okay, mean first step input your A into calculator. Second step input your B, okay, vector V as B in your calculator. Later on perform matrix multiplication A times B. If you do manually, I guarantee you have a lot of, okay, careless mistake. Then the rest will be gone. As well, I have marked halfway of your test. Okay, a lot of you get all kind of careless mistake. Okay, none of you can get, okay, I think 100% correct. Okay, after you get AVK, okay, remember just now, MK plus 1 is actually the maximum value in terms of magnitude from the AVK. So you have -1, 6, -1. Take the maximum in terms of magnitude. So it will be 6. So you get this 6. So mean when K0, this one is stand for MK plus 1. So mean this is M1. This one is M1. If let's say this one -6, so this will be MK plus 1. This is -6. But this is positive. That's why we take it 6. Later on, okay, so you, okay, complete row 0. Row 1 is actually you take this AVK divide by MK plus 1. AVK divide by MK plus 1 mean -1, 6, -1. This is a, okay, vector, column vector divide by 6. So you get here. Okay, so how to do it? Okay, your result. This is a, okay, max answer. Max answer actually your AVK here divide by 6. mk plus 1, you manually write down here 6. So you just take this one, max answer, divide 6. So your result, negative 0.1667 is here. K equal to 1, this value. And then 1, negative 0.1667 here. So now you have the new eigenvector. Mean this is V1. Initially you have V0. Okay, you have V0, AV0 you get here. Okay, from AV0 get the maximum, which is maximum intermagnitude is 6. Later on you get this AV0, which is stored in max answer, divide by 6. You get the answer V number 1. Okay, after get V number 1, repeat the process again. Take A multiplied by this one. This one, which is stored in actually max answer. This result. Mean the latest result is stored in the max answer. So now you may take A multiply your max answer. And then you may clear first AC. Option again, find Beck's metric A, which is number 3. Multiply. Option again to find K. Max answer is number 1. So I get here, okay, negative 1.5, which is here, 6.6667. Okay, when you go down, look at the value at the bottom, 6.6667. Okay, which is AV1. Okay, second value. Okay, and the third value, negative 1.5. So you complete this one. Okay, after you complete AV1, okay, you got 3 value here. Find the maximum, okay, in terms of magnitude, which is 6.6667. Okay, so you obtain this one. Then you're checking M2, because mk plus 1, when k is 1, this is M2. M2 minus M1, this is an error. Okay, the error here greater than epsilon. Hence, you need to proceed to the next row, which is k equal to 2. Okay, so the process is repeated. Okay, so the process is actually repeated. Now, okay, your latest k result is actually in max answer. So you take this max answer now, divide by 6.6667. So you just divide 6.6667. So this latest result is your latest K V1, V2. Now it will be V2, the next one, the next row. So 1, that's what you get here. So the process repeat, okay, until the error here, this one you see 0.004. Hence, okay, if this one less than 0.004, you need to, okay, mean you stop here. This is, okay, because when you stop here, this is M8 actually, because MK plus 1. You have MX, that's why you need to find V number 8. So you get, again, gets a max answer divide by, okay, M with the same row. Mean you take AV, this will be AV7 divide by M8, you get V8 here. Okay, so then you stop here. Mean when you, okay, see the errors here, less than epsilon, okay, the V, you still need to perform one more. Because this one, this value, this one is M8, M number 8. So you need to find V number 8. And then, okay, the reason you stop is actually sin M number 8, okay, because MK plus 1, M number 8 deduct M number 7, okay, which is this value. This one deduct this one, this value, less than 0.005. So the dominant eigenvalue for lambda 1 is actually approximate to the last mk plus 1, which is 6.9996. Mean the last k, the dominant k eigenvalue lambda 1, it will be the last mk plus 1, and its corresponding eigenvector will be the last one. Okay, make sure this is M8, this must be V, must be number 8. So it's negative 0.251, negative 0.25. Okay, because you check back, okay, okay, keep, you see back the theory here.
Doctor.
Yes. Yes. Okay.
For the M,
Yeah.
we just insert the K plus 1 only, right? The follow the value.
M is actually you got 3 value that pick the maximum. You see VK plus 1. given V as V naught, the initial eigenvector A times eigenvector AV naught, AV naught, you will get M number 1. And then you take AV naught divide M1, you get V1. That's why you look at the formula properly. This one K start from 0. K0. So you have given V0, you find AV0. AV0, 3 value. Get the maximum absolute value of AVK. That will be your MK plus 1. Mean given KV0, you will get M number 1. So with M number 1, you should get V number 1. That's why when you stop, so this is actually MK plus 1. When K0, this is M1. Mean given, right, mean given V naught, mean when you take AV0, AV0, find the maximum AV0 will give you M number 1. Given M number 1, your V1, V at step number 1 is actually AV0 divide M1. Yeah. So that's why you have M number 8, you should find V number 8. MK plus 1 here, the column AVK 3 value takes the maximum in terms of magnitude. If let's say this one is negative 6, in terms of magnitude, this value is the biggest. When you put MK plus 1, this one also carry negative. So that later on your max answer divide by MK plus 1, you also divide by the negative. Then we get the new eigenvector here. So just now, yeah.
Thank you.
So, is it clear? What is the question?
Yes, yes. Okay.
And can you find yeah, I don't have that old calculator with me. So the old calculator you have to find the way how you press metric multiplication. Because if you do manual, you sure have careless mistake and will time consuming. So can you get completed, or should we continue? I think it's the process is the same. Just repeat only.
Okay, sure, doctor.
The second example also, I think the same thing, because it's only we change metric A, we change the initial eigenvector. The process is the same thing. Find the largest eigenvalue lambda 1 and its corresponding eigenvector V1 using power method with V naught equal to 101 transpose. Stop the iteration until modulus MK plus 1 minus MK less than epsilon equal to 0.005. So it's the same thing, but I have to jot down. Hold on. Put this one. Oh, yeah. So it's the same thing here. I can AC number 4. Define metric A 3. Input again the new vector A metric A 5, negative 2, 1, negative 2, 2, 0, 2, negative 2, 3. So before you perform any calculation, double check whether you key in your metric A correctly. 5, negative 2, 1, negative 2, 2, 0, 2, negative 2, 3. So correct. And then you can AC to clear options, to define a new matrix. I think the ES or MS should be shift, I think shift 4, something like that. You find where on top is you got the C, they will jot down there is a matrix there. So define, we already have A, then we define metric B. 3 rows, 1 column. We key in as metric B in calculator. So the value is 1, 0, 1, 1, 0, 1. Okay, 1, 0, 1. So given V naught, calculate A V naught. V naught multiply A multiply V naught. You get the result in the second column here. Okay, in here, second one. So the result is a 3 row times 1 column. So to save space, we turn it, okay, row. That's why you see AVK transpose. Okay, so I clear. And then options. Okay, in the ES or MS should be shift 4 or shift 5. You check it. So you can define matrix. You can edit the matrix. If you already define, you have a error, you may edit it. Or just now, I no need to, okay, I can just, to input new matrix, I may just go to edit it. And then this new model, you can up to A, B, C, D, and max answer. Determinant, transpose, K, transpose, identity. Okay, so to do, okay, matrix A, number 3, multiply button. A multiply vector V is in input as B. So your option B is number 4. Click number 4. So you get 6, negative 2, 5. Here, 6, negative 2, 5. So 6, negative 2, 5. Here. Okay, and then from AVK column here, the maximum interval of magnitude is 6. So write down 6 here. So this is M number 1. This is M1. So with M1, you take AV naught divide by 6. Means 6 divide 6, 1. Negative 2 divide 6 here. 5 divide 6. Okay, you can use calculator quickly. Like here. So max answer. Because 6 negative 2, 5 is in max answer. Okay, you can straight away divide by 6. So 1. Negative 0.3333, negative 0.8333. So what I mean, standardize, okay, 4 decimal place. So this one don't want 1, 2, 3, 4. Standardize everything. Don't want to mix. Sometimes 1, sometimes 2, sometimes 3, sometimes 4. Very, okay, confusing. So 4 decimal place. Okay, keep up all the step 4 decimal place. So now repeat the process using A multiply V1. A multiply V1. V1 now is stored in max answer. You see here? V number 1 is stored in max answer. So you can take A time max answer. So you can AC first. Option, take A, multiply. Option, find a max answer. Number 1. So 6.5 here. Negative 2.6667. 5.1667 here. Mean the result A multiply V number 1 is here. K equal to 1. This is AV. Okay, this result is actually A times V number 1. So AV1 you got 3 value. Find the maximum intermagnitude is here, 6.5. So you jot down. This is M number 2. M number 2. Okay. With M2 you have to find V2. But before that, you see M2 minus M1. 0.5 greater than epsilon. This one still greater than epsilon. Proceed to find, okay, V2. V2 is actually take AV2 divide by M2. So mean you take this one, which is in max answer, divide by 6.5. So this one, max answer, now keep your result AV1. So takes your max answer, divide 6.5. So you have 1 here. Negative 0.4103, 0.7949 here, this part. Okay, max answer divide 6.5, you get V number 2. With V2, repeat back A times V2. Okay, A times V2. Your V2 now, Okay, V2 now you see, okay, all the latest answer is keep in max answer. V2 is keep in max answer. So you take A time max answer. You may clear first. Then option A multiply option max answer. Okay, so you get 6.61, okay, 54. So sometimes run okay a bit because this one I think is from Excel. Okay, negative, okay, 2.8205, run one digit because this result is obtained from Excel by rounding it to 4 decimal place. 5.2051. Okay, so you see, okay, calculator and the Excel run a little bit. So this max answer is actually your AV number 2. So okay, once you get AV number 2, find the maximum intermagnitude is this 6.6155. So this is M3. M3 deduct M2. Okay, you see this value. M3 deduct M2 is a absolute error 0.1155, still greater than epsilon. So proceed to find V3. V3 is actually your max answer divide 6.6155. So the process is repeat and make sure you focus, otherwise you will easily get mistake. So max answer now divide 6.6155. So and please take the value at the bottom. Here it display for you 0.9999, but you when you click, the value is actually 1 here. Negative 0.4263. Okay. 0.7868. So sometimes run one digit because different. This is Excel, this is calculator. Run a little bit. So you got V number 3. Okay, V number 3 also store in max answer. Later on repeat lah. A time max answer. So clear. Option 3 times option max answer. So you get 6 point here 6394. Okay, so and then this one negative 2.8527. Okay, 5.2131. So you repeat the process until your error here at step k equal to 6, you see the error 0.004. Mean you take this one is actually M7. This is M6 because it's MK plus 1. When row 6, this is M7. M7 deduct M6. The error, the absolute error is 0.004. This one less than epsilon. Okay, when you less than epsilon, you still need to find one more. Because you have M7, you need to find V7. Okay, so we obtain this one. So lastly, the last MK plus 1 will is actually indicates your lambda 1, which is the dominant eigenvalue. Mean lambda 1 is approximate equal to M7, which is equal to 6.6458, and its corresponding eigenvector will be V7. So V1, you see, lambda 1 approximate M7 equal to 6.6458, and then V1 approximate equal to V number 7, which is 1. Don't comma will be coordinate. This is initially is eigenvector. We turn horizontally row, so that's why I need transpose. So V7, 1, negative 0.4305, 0.7848. So the concept is easy, just you have to do metric multiplication. AVK. AVK. Mean given V naught, you find AV naught, determine M1. Later on, take your AVK divide by your M naught. You get V number 1. So repeat the process until MK plus 1 minus MK less than epsilon. Hence, if you stop at the MK plus 1, you need to find your VK plus 1. Then don't forget the conclusions. So this is about the finding the eigenvalue, finding the dominant eigenvalue using power methods. Okay, can you get the answer? Where is my mouse.